Good day, guys. Can you hear me? Yeah. All right. I'm Chris. A little bit about myself. So that, well, first off, we structure the talk or the session into two parts. So since it's only 20 minutes, so it's 10 minutes me talking about the platform. So we are a company which is enabling game developers to build multiplayer. And then the second part I hand over to Taras, who is coming from the game development side, using our tools in the VR space to leverage basically what I just told in the first part. So I'm in the industry since quite a while, since 2003. Back in the days, the idea we had, or the venture we started, was to build a turnkey backend as a service for mobile multiplayer. It was a time when Nokia phones were pretty popular. Nokia was dominating the whole space. I think the idea was pretty good, but it was horribly in terms of timing. So that took a while. And then about 9 years later, 2012, we still were in that space, multiplayer, and we decided to refocus and focus on real-time multiplayer. And that worked out pretty well. So we were able to get 190,000 registered developers. Among those developers, a lot of big companies like Oculus, Glue Mobile, Square Enix, Disney, or Ubisoft. So we're really proud of that. But on the other hand, we have a lot of indie developers, hobbyists, students, kids who are using our tech. And we are building a software as a service, so everybody can use us, and we now have more than 70 million players every month using our services. Okay, so I won't make, well, just a question. So who's technical in this session? So, okay, a couple of you. So I will not make it too technical. So if you want to have a deeper dive, let's say, you can approach me. So we have a little booth upstairs. So the talk is about Netcode. So Netcode is basically used as a term when it's about networking in online games, and usually it's used in a more negative way, let's say, if games are lagging, basically. So multiplayer is pretty straightforward. So the game design goal, you have a virtual world, a lot of players, and this talk is pretty much focusing on VR. And you want to have a magical experience, right? So you work or you play with other players, or you experience the world with other players. A couple of samples, so Ubisoft Eagle Flight, I don't know if you guys played it, or Star Trek, Bridge Crew, or Facebook, social. So you're playing the game and you're seeing the other players, and everything feels really seamless. So the challenge is pretty simple. So you just need to keep the game state synchronized across machines without lag. So that's about it. So that's multiplayer. In fact, it's not that simple, because the main issue, of course, is latency. And latency is there because players are connected with different distances. So it's limited to the speed of light. So there's something between 50 milliseconds and 200 milliseconds latency there. In VR, it's in particular a challenge to do multiplayer, because in some games, and a lot of people think about games where you are using objects that you are sharing, that the complete environment you are sharing with your opponents. So for example, take a table tennis game. You are playing the ball, and the bats are used by your hand controllers. So every movement you want to transfer it as fast as possible. And so as a player, you would expect the movement to be instant. On the other hand, the other player, if you hit the ball, you have to display all this in a totally correct manner. So that's a challenge. Or if you have fighting games, or if you are interacting in the same space, or in this case on the right side, there's like a slingshot game, so you're trying to destroy the castle of your opponent. So technically, there are 3 basic models to implement multiplayer. And due to the time constraint we have today, I just focus on 2 methods. One is called lockstep, which is, for example, is becoming more popular. Again, it was initially invented in Doom, so a pretty long time ago. And recent games using it are games like Clash of Clans, for example. And snapshot interpolation, which is a way of transferring state, and I'm digging a little bit into those. Okay, so first model, deterministic lockstep. Like I said, used by Doom back in the days. So how do you keep the game state in sync? You exchange input. So in the table tennis sample, instead of exchanging every movement, you are exchanging, okay, I hit the ball. Or in a real-time strategy game, instead of synchronizing hundreds of units, you are actually just synchronizing the clicks of the keyboard. So that's a trick. That sounds simple in general. It is. So the data that is flowing back and forth between the clients is pretty small. But you have to make sure that every client receiving that input is actually generating the exact same output. So it needs to be a deterministic engine. So here I visualize it. So let's say you have 4 players on the right side. You are sending across the input. Every peer is using the same input to simulate the world. The other peer is using the same input to simulate the world. And the beauty of lockstep is that if you have a proper lockstep engine, which is deterministic, you have exactly the same world representation on every client. But there's a big downside, which is because you have to wait until the other side receives your input, you have to cover the input delay. In lockstep, it's called the input delay. So that can be quite a challenge. So if you play Clash Royale, for example, you will recognize that everything you do is kind of there's a delay implemented in the game, which is kind of pausing the game for a couple of 100 milliseconds, basically. So there's another model, snapshot interpolation. So how do you keep the game in sync? Instead of sending input and then every client is building the world, you are sending around state, basically, and simulating locally and kind of interpolating everything. So the beauty is it's instant. So everything you do is, because you simulate locally, it's super fast, but all the data you get from the other players, all the state is old. So it's 50, 100, 150 milliseconds old. So you actually need to cope with it. So you need to figure out, okay, what happens in case of something goes wrong. So in summary, there are 2 ways to deal with latency. One is you put in an input delay and use lockstep. The beauty is you have the exact same physics world. The other one, you deal with latency later on, and that makes the lag compensation pretty tricky. So we have 2 products. Well, we have more products, but 2 products which fit that. So we have one product called TrueSync, which is using that lockstep approach, and we have a product called PAN, which is using that snapshot interpolation approach. And so we wanted to enable VR developers to give the VR developers samples to actually learn from what we are doing. So we said, okay, we try to find a studio to build sample applications. And this is how we came across Taras and his team from Nix, who had quite a bit of experience in VR development. So we decided, okay, let's cooperate and build some samples, which we are going to put into the Unity asset store for everyone to download and experience that as well. So I will hand over to Taras.
Thank you, Christof. So I would like to introduce a little bit of myself. So I am leading the game development and VR studio at NX, so it's a company in Ukraine. We have 1.5 years experience with VR, so we started it quite early, as soon as we get some devices to work with, and also we focus on the multiplayer. So we work a lot with Photon, and we actually think that's quite one of the best solutions for the multiplayer on the market that is right now. So I will talk a little bit of VR. I guess you know most of the things already. What is it? And already tried it. So, but for me, I think of it as, for example, if you close your eyes, you see some world like in that darkness, and actually it's sort of an imaginary world. So idea of the VR is not new. It started a long time ago, and everybody now the technology gives you more opportunity to develop on it. When you have some experience, you always want to share it. So, and another important thing that in terms of this conversation, it's that you would like to share it with others and participate with somebody else in there. So also VR gives you a new form of interaction. So previously you had mouse and keyboard, for example, to control your character and to play the games. Now you have controllers, you have hands, you have head tracking, and this gives you more complication and more advantages to writing multiplayer code and actually the experience itself. So the main challenges that are related to VR is movement. Everybody knows that the motion sickness, so I will not stop there a lot. Another interesting thing that is quite related to the multiplayer experience is player and avatar and its appearance in the virtual world. So for example, everybody is okay when you run with your dwarf into some elf in World of Warcraft, but if that happens in VR, that can be a bit tricky. So that's another level of interaction, and there could be some other obstacles for that. Also, people used to natural and intuitive experience. That's why we want to see in VR something that we feel okay with us as we see it in real world. So in our company, we decided to work on VR in autumn last year. So we gathered a team and let's do some prototyping. So we did 5 prototypes, and one that we stopped and developed, and actually we want to publish this game on Steam at some time, is VRX. The basic concept is that you have platforms, the world with platforms, and the player stands on one of this platform, and opponent is standing on another. And the controls is pretty straightforward. You have one hand to teleport to another platform, and another hand you use to fire and to destroy that platform. So when we tried this one gameplay in our studio and then in some local public, actually it was quite fun and especially very dynamic. So you have to move fast, and it was quite fun. Speaking about the development itself, so about these 2 models that Christof talked about, so we're working together with Exit Games on few demos, and one of them is Slingshot. So the idea is quite simple. You have 2 platforms, you have 2 players, and the goal is to destroy the castle, in this case 4 boxes of other player. For this we use lockstep, and actually the mechanics looks like that. So you have a string, you have in hand you have a ball, you need to put some tension to it and then release it to shoot. We used for this the lockstep technology for the physics and for the simulation, and the main thing that we synchronized over the network was the direction of the shot and the power of the shot. So everything else was simulated on each player machine in the same way because we use deterministic model, and if you have the same input, the same comments, it is the same on both devices. Also, to make more fun for this, you can add pan to simulate the actual position of the players, movement of the heads, but that's actually another demo. So another demo is about shooting things, and it's quite simple and straightforward. You have a row of players, and everybody has a gun in hand, and there's a moving target, and you're shooting to that target. The main thing, and the main advantage of it, that you can see your opponent. In this case, you see the position of his gun, but it can be easily transferred to working with the full body. By the way, there is another problem that you can experience when you're working with a VR and multiplayer, is that, for example, Vive, they have tracking of the hands and head, and you don't have legs. So usually you need to design in that way, so either it is not important, or actually you have a character without legs, like a ghost or something like that. So that's another point. So in this case, everything looks fine. So you have everybody, and you see everybody, they are shooting, but the main question how to determine who is the winner for that. And for us, like we used the approach, like standard approach in the multiplayer. It's about the master client. So there is a client one who decides who actually hit the target, and in this case, the low lag you have, latency to the server itself, it's the better for you. And for the master client, who is who is the main decision maker in this process, it's like he has a lot of advantage. But you can, for example, generate traffic on the master client through the server, so he will be in more or less the same situation as all other clients. So yeah, basically, like we learned a lot on this, and in 10 minutes or in 20 minutes, you cannot talk a lot. And also, I didn't show any code here, so maybe you thank me for that. But it will be available in the Unity store, so we'll publish there an asset that will have both lockstep and PAN SDK for the VR, so it will be compatible with different headsets, and you will be able to check everything and make it as a base for your games and experience. So yeah, thank you. So hope you find it useful.